Good evening, guys. Am I audible?
Yes.
Yeah. Okay. So hope everybody who is present here all were present yesterday, or at least have visited the yesterday's session video. Is there anyone who has not visited yesterday's session's video or was not present yesterday? Okay. So everyone was present, right? So shall we begin? Okay, guys, actually, yesterday we had discussed about the centrifugal pump and gear pump, right? So, yesterday we have discussed about the how the pressure is created at the discharge side and how the pressure is created at the suction side and the parts of centrifugal pump working principle, gear pump, etc. Right? So, today we are going to discuss about the types of pumps. Okay, so actually we should have discussed it yesterday only, so we are going to discuss it today. Uh, can anybody say what are the types of pumps? Hello, guys. Can anyone say what are the types of pumps?
There are two types of pump.
Yeah. Okay. Please go ahead.
One is rotodynamic and another is positive displacement.
Yeah. Okay. Uh, that's it.
In that, there are many classifications.
Yeah. Please go ahead. Please tell the full answer.
Like in rotodynamic pump, there are centrifugal pump, axial pump. In positive
Hmm.
displacement, there are diaphragm pump, piston pump.
Okay.
Okay. That means positive displacement, reciprocating pump, and rotatory pump.
Hmm.
In reciprocating pump, diaphragm pump and piston pump. In
Hmm.
rotatory pump, screw pump and wear pump.
Okay. Okay. So anybody wants to tell the answer in different way, or wants to add some other points?
Yes, yes. I only want.
Yeah. 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 Go ahead, Sagar.
No, no, you tell.
Yeah. Okay. So basically, guys, there are two types of pumps, as Sagar said. One is a centrifugal pump, and another is a positive displacement pump. Okay. So in positive displacement pump, we have categorized into two types. That is reciprocating pump and rotary pump. Okay. So in reciprocating pump, there are two types of pump. That is diaphragm pump and piston pump. Okay. So in piston pump, it's like there are again two types: single acting pump and double acting pump. Okay. So can anybody say what is single acting pump and what is double acting pump? Anybody?
Sorry, please come again.
Okay. So in reciprocating pump, actually there are two types: diaphragm pump and piston pump. Okay. So in piston pump, there are again two types. That is a single acting pump and double acting pump. So my question is, do you guys know what is single acting pump and what is double acting pump?
Uh, I know. Can I explain?
Yeah, yeah, please go.
In single acting pump, inlet wall and exhaust will be at the one side only at the top. In double acting pump, inlet wall and exhaust will be on the both sides at the bottom and the top.
Okay. So what is the use of that? What happens if there is a inlet and outlet at one side, and what happens if there is at a both side, top and bottom?
Actually, in single, there will be only one piston acting. No, in
One piston. I'm not clear. Uh, will you go it again, Sagar?
Single acting, no, only one piston will be there, no. I mean, one chamber of piston will be there, no. In double acting, there are two chamber of piston will be there, isn't it?
No, no, no,
Not sure.
no. Actually, in single acting, what happens is when the piston is reciprocating, right? The action takes place only when the piston moves towards TDC, that is top dead center. Okay, so fluid is forced to flow when the piston is going upwards or the top center at the top position. While in the double acting, the discharge is happening when the piston is coming down and up because there are two ports. Okay, the inlet port and outlet port is at the bottom side also, and the inlet port and outlet port is at the top side also. So the reciprocating action creates a continuous suction and discharge. That is the double acting. And in single acting, once when the piston goes down, there is a suction, and when the piston goes up, there is a discharge. So only one action is happening at a single time. Whereas in double acting, it is not like that. When the piston is coming down, one side there is a suction, and another side there is a discharge. When the piston is going up, from bottom side there is a suction, and at the top side there is discharge. So that is known as double acting.
Can you
Did you
give
get
the
guys
any application of double acting pump?
double acting pump applications?
Yeah, where it
Uh,
is used.
Sorry, I'm not clear on that. Actually, I don't know that. Do you know it?
Okay. No, no, I don't know. That's why
Uh,
I'm asking to you.
yeah, okay. Let's find it out. Let's find it out, guys. Okay, anybody here knows what is the application of double acting pump?
I think air open diaphragm pump is a double acting pump.
Diaphragm pump.
Yeah, yeah, vent diaphragm, air open diaphragm pump.
Yeah, okay. So I'm not clear. Actually, diaphragm pump is how come it
I
can be double
just
acting?
I just googled uh,
Yeah,
oil ring hand pumps and also in auto or fire extinguishers due to high pressure discharge of this
yeah.
pump. We use this one or double acting pump.
Okay. Yeah.
I think so. Double acting pumps are used in automobiles, also in aviations. Everybody knows about the landing gear of airplane.
Hmm.
Anyone knows the landing gear of airplane? So, in that landing gear, hydraulic power is used. So, to pump that hydraulic energy, double acting pump is used. Most of the cases, double acting is used.
Okay. So like I'm asking where on board ship in marine that is about aviation. Actually, Gulshan
Maybe
was asking. Yeah, go ahead, Sagar.
On
just wanted to ask one thing. So in fire engine, no, which type of pump is used in fire engine?
Fire engine,
Yeah, this one red engine will be there, no, emergency.
What emergency fire pump, na?
emergency fire pump.
Fire engine.
Is it single acting or double acting?
Actually, I'm not clear, guys. I'm not clear on this. Sorry. Just a second. Yesterday we had discussed in applications about emergency fire pump, right? So centrifugal pump is used there in emergency fire pump. There is the high discharge and low pressure, right?
Yes, yes.
Yeah. So this is a positive displacement pump. I don't think in fire acting pump we are using this double acting pump. The centrifugal pump is used there. We had discussed it yesterday, right? In the applications of centrifugal pump. Hope you're clear.
Oh, yes, yes.
Yeah. No. Did you get the meaning of single acting pump and double acting pump? Any more doubts on this? Single acting and double acting?
Akshay, if you have any like example with the animation video, so please show it on your laptop now.
Animation video of double acting pump. I am not having it. Just a second, I will search it.
Okay,
Could you
okay,
guys please wait for a minute? I will just search it.
okay, okay, okay. We are waiting.
Yeah, sure. Yeah.
I missed this topic.
Sorry.
Single acting pump and double acting pump. Explain please, sir.
Yeah, yeah, yeah.
There is a good news and bad news for you. If you are using Microsoft,
Yeah, I got on animation, guys. Just a second, I will share it. Is my screen visible to everyone?
Yes.
Yes.
Yeah, yeah, okay. So here it is. There are two ports as you are seeing there, inlet and outlet. Yeah, now it's clear, guys. Can you see that the action is taking place both in upside and downside motion? Can you see that? Hello.
Yes. Yes.
Is this clear, guys, or should I show some other animation videos? That was on
Okay.
double acting
We
snake.
can move on another question.
Yeah, okay. So the next question was, just a second. Why the positive displacement pump is called as positive displacement pump, guys? Why a positive only? Anyone? Hello? Am I audible?
Yes. Yes.
Yeah. Why positive displacement pumps are called as positive?
Why
Why
only?
not only displacement pumps? Why only positive displacement pumps? Anyone? Okay.
I think
Uh,
so. Due to the flow of the fluid, it can only flow in a forward direction. That might be one reason.
yes, correct. That's the right answer actually. In positive displacement pump, the fluid action, flow of fluid action takes place in only one direction, that is towards the discharge side. The fluid never comes towards the inlet side. It never returns back. Okay, so that's why those pumps are known as positively displacing pumps. Okay, they are positively pushing the fluid towards the discharge side with high pressure. Okay, so any doubt on this?
No.
Yeah. Okay. So the next question is uh, difference between gear pump and reciprocating pump. Anybody wants to explain this? What is the difference between gear pump and reciprocating pump?
Reciprocating pump is basically the example of a positive displacement pump. It works on the basis of plunger, piston, and cylinder. And gear pump is basically two basic gears per gears are meshed inside a casing, and due to the meshing, the volume is reduced and compression is created, and the fluid is flowed to the discharge side. Basic difference is the pressure and flow is more in positive reciprocating pump, and in gear pump basically any type of heavy or high viscosity fluid can be flown through the gear pump.
Okay. So any other points, guys? Anybody? There are actually many points to be added here. Any other points you want to add? Anyone? Okay. So should I tell?
Yes, go
Yeah.
for it.
So basically, gear pump and reciprocating pump, guys. First, let us divide it by mechanical elements. Okay. So what are the mechanical components used in the gear pump and reciprocating pump? So in gear pump, we are using gear tooth. Okay. As Parth said, we are using gear tooth. And in reciprocating pump, we are using piston and cylinder. Right. So when it comes to the principle, the gear pump acts on the principle of meshing of gears. Okay. And the reciprocating pump acts on the principle of reciprocating movement. Okay. So the gear pump function is it is having the low pressure range, and the function of reciprocating pump is it is having a high pressure range. So depends on the application we are using gear pump and reciprocating pump. Okay, so where we need high pressure we use reciprocating pump, and where we need comparatively low pressure we use gear pump. Okay, so next is the construction. The construction of gear pump is very simple because there are only two gears within the casing and those are meshed. And the construction of reciprocating pump is bit complex. Okay, and when it comes to assembling, gear pumps need very less space, and reciprocating pumps need a bit more space. Okay, so and when it comes to the pressure range, gear pump operating pressure is up to 300 to 350 bars, and reciprocating pump operating pressure is up to 700 bars. Okay, and gear pumps are bit noisy because due to the meshing of gears, the noise produced is bit more as compared to the reciprocating pump, and in reciprocating pump the noise is bit less. Okay, so next is delivery. So, guys, in gear pump, um, the gears are continuously rotating and the fluid is stuck inside the gear tooth. So, the delivery is continuous there. Whereas in reciprocating pump, it takes the time when there is a reciprocating action. It takes bit time to deliver the fluid continuously. So the delivery is intermediate as compared to gear pumps. So in gear pumps, the delivery is continuous, and in piston pumps, it is piston pumps or reciprocating pump is it is intermediate. Okay. So next is maintenance. The maintenance of gear pump is very affordable, like it is cheap, and in reciprocating pump, it is costly. Okay. So next, when it comes to the types, there are three types of gear pumps, as you all guys know. One is the external gear pump, internal gear pump, and another is the screw pump. Okay. And when it comes to reciprocating pump, there are two types, that is axial piston pump and radial piston pump. I hope you guys know what is the axial piston pump and what is the radial piston pump.
Can you share
Anybody?
the picture of this difference between reciprocating pump and gear pump? Okay, in the group.
Uh, difference between gear pump and reciprocating. You need a difference.
Yeah,
Yeah.
yeah.
I have written it down. I will just share a screen. You guys can note it down or you can take a photo. Just a second. I will share it in the group, guys.
Okay.
Yeah. I have shared it in the group. Did you guys receive it? You guys can make a note of it.
Of course.
Yeah. So, is there any doubt in this? The difference between reciprocating pump and gear pump? Anybody? Anybody? Is there any doubt in reciprocating pump and gear pump?
No, no.
Yeah. Okay. So I have shared the pic of my notes. So if there is any doubt, then you can contact me here, or you can contact in group also. So shall we move forward?
Yes, yes.
Sure.
Okay.
Sure.
So what is the difference between centrifugal pump and positive displacement pump, guys? Anybody?
Yes. First of all, let's start with the construction. Construction of the centrifugal pump is bit complicated,
Okay.
or it's bit it takes effort to construct a centrifugal pump. And if we talk about positive displacement pump, it is a slightly easier process, or it is not much complicated than centrifugal pump. And if we talk about centrifugal pump, discharge is radially outwards,
Okay.
and in positive displacement pump, discharge is actually outwards.
Okay.
And cost of centrifugal pump is quite high than the I think so. I'm not sure about this, but I think so. It's quite high than the positive displacement pump. And basically propellers, or what we call about
Impeller.
propellers or vanes of the centrifugal pump are designed in such a way that are designed with a metal of high carbon structure, such as a mild steel, stainless steel, mild iron, we can say. And positive displacement pump, material matters, but mostly it is upwards and downwards reciprocating motion. So motion is quite fast.
Okay.
So material is there also material is obviously high carbon, but not as compared to centrifugal pump.
Okay.
And positive displacement pump is used for high pressure head.
Mhm.
And centrifugal pump is used for flow, continuous flow, not for a high pressure head.
Okay.
Flow for a continuous and fluent flow. And positive displacement pump are self-priming pump. Mostly they are self-priming pump, and centrifugal pump are they can be self-priming also, and mostly they require priming because of the cavitation and all. So these are the
Okay.
some of the differences. And one difference I think so I forgot in construction. The casing of the centrifugal pump is volute casing,
Mhm.
and uh, this positive displacement pump casing is a cylindrical shape, or we can say rectangle.
Okay. So you mentioned that in reciprocating pump it is a self-priming pump. So I have not heard that reciprocating pump or positive displacement pumps they need priming. So is it 100% sure that they are self-priming or they need priming? Can anybody confirm this?
It's confirmed. Priming is not required for
Yeah,
the reciprocating pump.
yeah,
Yes, I think so.
because
Priming is not required for positive,
yeah,
as there
because
is
they are
no
yeah,
chances of cavitation.
yeah, right. Because they are positively displacing the fluid with a higher pressure, na? So there is no chance of getting air bubbles inside that positive displacement. So priming is not required there. Okay. So anybody wants to add some more points to this? Is there anyone who
We
wants to
can
add some
say
more points?
maintenance is more and costly for the reciprocating pump, and maintenance is less and cheap maintenance for the centrifugal what kya positive displacement pump.
Centrifugal. Okay. So actually, Parth had mentioned that the cost of centrifugal pump is more as that of reciprocating pump. So actually, it's vice versa. The cost of centrifugal pump is less and the reciprocating pump is high. Am I right or am I wrong, guys?
It's right.
I wasn't sure about it, but I think so. Okay.
Yeah. Okay. So actually, I got confused. I also got confused.
Sometimes it depends on uses of the pump, whichever we are used. Okay, now.
Yeah. Oh, yeah. Yeah, right. But generally, centrifugal pump is compared as cheaper than reciprocating pump. When
Yeah, we
we
can say.
yeah, yeah. Okay. So yeah, let's continue. I will tell this answer. The difference between centrifugal pump and positive displacement pump is, guys, first let us begin with the working principle. So centrifugal pump works on the principle of centrifugal force and positive displacement works on the principle of positive displacement. And when it comes to flow, flow varies with the head in centrifugal pump. Okay. If the head is less, then the discharge is more. If the head is more, then the discharge is less. Therefore, the flow varies with the head in centrifugal pump. Whereas in positive displacement pump, the flow rate remains constant because it is displacing fluid positively and with a higher pressure. It is displacing the fixed amount of fluid. The fixed amount of fluid is trapped inside the cylinder and it is moving towards the distal side. That means the flow is constant in the positive displacement pump.
Yeah, yeah.
Okay. Yeah. And in centrifugal pump, the flow rate decreases with increase in viscosity, but the flow rate decreases with increase in internal clearance in positive displacement pump. Okay. What do you mean by internal clearance, guys? What is internal clearance? Anybody?
Clearance between piston and cylinder.
Clearance between piston and cylinder.
Head, piston head and cylinder head.
Piston head and cylinder head. Okay, so basically, you are speaking about the volume of the cylinder, right?
Mm,
Or the stroke length.
stroke length, yes.
Yeah. So is it right, Gulshan?
No, bro, I don't know.
Yeah, okay. Actually, I am also a bit confused about the topic of internal clearance. Maybe I think that it is the stroke length that is the internal clearance because as long as the stroke length, that much of fluid is displaced. More the stroke
Yeah.
length, more the fluid is displaced. Right?
Yes.
Yeah. Okay. So in centrifugal pump, the flow rate decreases with increase in viscosity. So is this point clear?
Yes,
All of you guys understood this point? Like as the viscosity increases, the flow rate decreases in centrifugal pump. Is this point clear? Hello?
Guys, please respond it. Yeah, you are only just coming here and then stay down. So it's not
Yeah,
good for
actually,
us.
I am not getting whether you are getting or not. I am confused. At least response in yes or no.
Yeah, yeah, I am also saying like this.
So
Please
you
respond.
are you're saying that if the viscosity increases, the flow is decreased in centrifugal pump, right?
Yeah, right, right. Correct.
Okay. Huh.
Yeah. I
And
was
what
just asking
about in
whether
positive?
in positive displacement pump the flow rate decreases with increase in internal clearance. He is saying that the flow rate decreases with increase in internal clearance. So I am also not
Viscosity
clear.
also might be one of the factor in positive.
I don't think so because viscosity doesn't play a major role there because it is positively displacing. Now it is pushing the fluid positively. There is a piston, so whatever it is displacing the fluid with the same pressure. So I don't think viscosity is acting. That's why he has given the concept of internal clearance.
Okay.
Yeah,
But what is exactly internal clearance?
yeah.
Is it
That's
about
so.
the stroke length or what exactly?
Yeah, actually, I don't think so. It is about the stroke length. Let me find it.
But
Just a second.
I think internal clearance means stroke length because when stirred coming from the bottom dead center to top dead center, it's a lot of clearance, internal clearance or gap, है ना?
Mhm. Okay.
I think.
Just a second, guys.
Hello.
Actually, I don't think it is stroke length because he is saying that as the internal clearance increases, the flow rate decreases. Uh,
I think internal clearance means when pistons starts move upward direction. Okay,
okay.
when it reaches to top dead center,
Uh,
there is some distance between the cylinder and piston.
hmm,
You know, where in engine piston cylinder, there is a
hmm.
gap where combustion takes place.
Yeah, right, right.
Yes,
So
between the
that is the
cylinder
that
head and piston top dead center.
that is the
Yeah,
clearance. I think
yeah,
that
that
is
is.
the clearance.
Yeah, exactly. That's the clearance. The distance between the top dead center and the piston is the internal clearance. And he's saying that as that clearance gap increases, the flow rate decreases. So that's about the reciprocating pump or a positive displacement pump. Okay. So up to this, is it clear?
So
Yes.
means internal if internal clearance is more, so discharge is less.
Less.
है ना?
Yeah.
Less.
Discharge should be
If
less.
internal
Yes.
clearance is more less, if discharge is more. Discharge is more,
Yeah.
no?
Yes, correct.
Got it,
So
got it.
yeah, okay. So shall we move forward? There are a few more points to discuss in this. Uh, When it comes to efficiency, in centrifugal pump, the efficiency is affected by the pressure. Okay, if the pressure is low, think if the atmosphere, if the centrifugal pump is creating less pressure as that of atmospheric pressure or the outside pressure, then the efficiency of the centrifugal pump decreases. Am I right? Because there will be no proper discharge at the discharge side. There will be no proper flow of fluid
Yes.
as
Yes.
there is
Right.
no
Right.
proper suction pressure is created inside. Therefore, there is no proper discharge, and that's why the efficiency of the centrifugal pump decreases with the effect of pressure. Pressure plays an important role in centrifugal pump, right?
Yes.
Yeah. Okay. So on the other side, in the positive displacement pump, it is said that efficiency is constant with increase in pressure. He's saying that efficiency doesn't change irrespective of pressure. Whatever pressure it may be, efficiency remains same. Efficiency doesn't change here with respect to pressure. Whereas in centrifugal pump, efficiency varies with respect to pressure. Okay. So is this point clear?
Yes.
Yes.
Yeah. Okay. So next, in centrifugal pump, load is directly proportional to the discharge. That is flow. And in positive displacement pump, the load is directly proportional to the pressure. More the pressure, more the load. And in centrifugal pump, the more the discharge, more the load. In centrifugal pump, load is directly proportional to discharge, and in reciprocating pump, the load is directly proportional to pressure. Okay. So is this point clear, guys, or is there any doubt? Clear, right? Yeah. Okay. So next, about centrifugal pump, it is used for high volumes and less head or low discharge. And positive displacement pump is used for high volume, high pressure. Obviously, we all guys know that reciprocating pump is used for a higher pressure and low discharge, and centrifugal pump is used for low discharge, low pressure and high discharge. Okay, so that was about centrifugal pump and reciprocating pump or positive displacement pump. So, is there any point to add, or have I missed something in this case?
In centrifugal pump, we do not use the relief wall, right? And positive
Yeah,
displacement pump, we use relief wall.
yeah, correct. Correct. In
That's one thing.
centrifugal pump, we do not use relief valve, and in positive displacement pump, we use it. Right. So, any other points?
No, it's okay.
Yeah, Gulshan, you want to add something?
No, no.
Okay. Uh, okay. So, shall we move for the next question?
Yes.
Yeah. The next question is about NPSH guys. Net positive section head. What do you mean by net positive section head NPSH? Just a second, I will share a diagram of centrifugal pumps. We need to go back to this. Just a second, I will share the screen. Yeah. Is this visible, guys? Is the diagram of centrifugal pump visible?
Yes.
Yeah. Okay. My question was, what is NPSS, net positive suction head? Anyone who wants to say,
I
or
think
anybody who knows it? Yeah.
NPSH represents the how much amount of suction pressure head
Okay.
present at the inlet of the centrifugal pump
Hmm.
and which is above the vapor pressure. Okay.
Okay.
Also, NPHs help us to avoid the cavitations point or to find the cavitations point where cavitation is happen.
Yeah. Okay. So, to avoid cavitation, the NPSS should be less or should be more above the vapor pressure.
It's above the vapor pressure but below the atmospheric pressure.
Okay. So, NPSS should be positive or negative to avoid the cavitation.
NPS is always positive. If we want to avoid the cavitation in a
Yeah.
centrifugal pump.
Yeah. Correct. To avoid cavitation, the NPSS should be always positive.
Positive.
Yeah. So, NPSS is basically guys net positive suction head. So, in this diagram, you can see that there is uh, HD and HS mentioned. That is head, suction head and discharge head.
Delivery. Yes.
Yeah. Can you see that HS and HD?
Yes, suction head and
Yeah.
discharge head, right.
Yeah. Yeah. So net positive section head is all about just the suction side, not the discharge side. Okay. So the head which is available at the suction side is the suction head. That is net positive section head. So actually, net positive section head it is calculated in actually there are two parameters in net positive section head. One is net positive section head available, and another one is the net positive section head required. Okay. So the net positive section head available is to be calculated, guys, and the net positive section head required is given by the pump manufacturer. Okay, so the net positive section head required is it is a minimum pressure required at suction port of pump to keep the pump from uh, cavitating. Means the minimum pressure required to avoid the cavitation is the net positive section head required, and the net positive section head available is to be calculated. Okay, so Do anyone guys know what is the formula of net positive section head available to calculate? How to calculate the net positive section head available?
There is a one formula we have that is a U1 square upon 2G plus P1 upon G plus H minus rho V upon rho G.
Okay. So that is the formula for net positive section head available. Okay.
Yeah.
Yeah. Actually, I am not clear about the formula which you had said. I have noted down the formula from the Trimmers package, which Pranit Mulka sir had discussed. So it is something like this: MPSHA is equals to HA plus or minus HZ minus HF minus HVP. So here HA, yeah. So here
Your voice is
HA,
not clear.
sorry.
Your voice is not clear.
Okay, just a second, just a second. Actually, yeah, my earphone charger is down. Just a second. I will switch to speaker. Hello.
Yeah.
Yeah.
Yes.
Continue, continue.
Yeah. Uh, Hello.
Yes. Yes.
Yeah. Sorry, there was actually a technical issue. Okay. So here the NPSHA formula is given as HA plus or minus HZ minus HF minus HVP. So here HA is the absolute pressure on the surface of the liquid. Okay, on the surface of the liquid in the sense where on the water reservoir, on the surface of water there is a pressure. Okay,
Okay.
so that is the absolute pressure on the surface of the liquid. What
Yeah.
is the absolute pressure, guys?
Got it.
Atmospheric pressure plus
Gauge pressure. Yeah,
gauge pressure. Yes,
yeah,
sir.
yeah. So that's the absolute pressure. That is HA on the surface of the liquid, and HZ is water head. The water head available. Okay, the water head available is HZ, and HF is frictional losses. What are the frictional losses, guys? What are the frictional losses in centrifugal pump? What are the causes of frictional losses? Why is there frictional loss in the centrifugal pump? What are the causes, or what are the parameters that affects the frictional losses? And what are the parameters that are responsible for frictional losses? Anybody?
Length of suction pipe,
Yes, correct.
and second thing is there is a
Yeah,
casing diameter,
yeah,
and another one is the delivery pipe.
yeah, correct. And another thing,
Another thing
the
is
another main thing is viscosity of the fluid, guys.
yeah, viscosity.
Yeah,
Yes.
yeah. So as the viscosity increases, the friction between the suction pipe or delivery pipe and the fluid increases. There is more friction as there is the as viscosity increases, the friction increases, right?
Yes.
Yeah. So these are the so HF is the friction loss and HVP is the absolute vapor pressure. So what is absolute vapor pressure, guys? What is vapor pressure? What is vapor pressure? So vapor pressure is defined as pressure required to boil liquid at a given temperature is known as vapor pressure. The pressure required to boil the liquid at given temperature. For example, what is the boiling temperature of water, guys?
100 degrees Celsius
Okay,
at 1 bar.
yeah, 100 degrees Celsius at 1 bar, right? So absolute so vapor pressure is 1 bar here. Okay, above 1 bar, the water forms a vapor. Okay, so 1.1 bar or 1.2 bar it forms vapor. So that is the absolute vapor pressure. So at a given temperature, actually vapor pressure depends on the temperature also, right? So as the temperature changes, the pressure also changes. Correct? Am I
Yes,
right,
yes,
guys? Or am I
Yes.
wrong?
yes,
Yes.
yes. You're right.
Yeah. I will just send the formula in the group. Okay. Just have a look into it. The That is the formula for NPSHA, that is the net positive section and available. Okay. So it is very important to calculate the NPSHA, net positive section and available. Gulshan, you were saying some different formula. So will you please share it in the group?
No, here is a. I have some formula for this, but it's fully depends on kinetic energy, potential energy, and pressure energy. All of the equal.
Yeah, yeah,
Yeah, that's it. But which is sent by you, which is sent by you in group.
yeah,
This is easy compared to this formula.
yeah. That's very easy. Actually, this is given by Pranit sir in demo package. I find it very easy,
Yeah.
guys, and he has
Uh,
explained it in very simpler manner.
and I am making from the Gyan notes.
Yeah. Okay.
Yeah.
So is it clear about net positive section hand, guys?
Yes.
Yes. Yes.
Yeah. Should we move forward, or is there any doubts on net positive section? I have sent the formula. Just have a look into it. If there is any doubt, please let me know.
It's very easy. Huh?
Yeah, yeah, yeah. Absolutely, it's very easy. Okay. So should we move forward?
Yes.
Yeah. Okay. So the next question is, guys. Just a second. So the next question is about sealing box or stuffing box or gland packing. What is sealing box and stuffing box and or gland packing, and why is it important in centrifugal pump? Anyone?
Can I?
Yeah, yeah, please.
Stepping box or sealing box, it consists of the gland packing and lantern ring.
Yeah,
Okay. So we know that in centrifugal pump there is some clearance between the impeller shaft and the casing.
yeah.
Okay. There is some chances of water leakage from this clearance.
Mhm.
So we provide the gland packing into this clearance to avoid the leakages.
Yeah,
Okay, but there is a continuous rotating motion between the stationary casing and rotary shaft of the impeller. So
yeah,
the temperature of the gland packing is increased because of the friction.
yeah,
Okay, so we provide we have the Latin ring
yeah.
which provide the over the fluid which provide the fluid over this gland packing, and it reduces the temperature of the gland packing,
Yes,
and
correct.
it's save from overheating.
Yeah,
Yes. Yes.
yeah, correct. So there are actually two types of seals. One is the mechanical seal, and another one is gland packing. So where the mechanical seal is used and where the gland packing is used? Any idea, guys?
Gland packing.
Where we use lubrication oil
Yeah.
or oil purpose.
Oils.
When we use pump for oil purpose, where we use the mechanical seal.
Okay. Yeah. Oils or fuels. We use mechanical sealing, and
Yes,
for or seawater line and all, we use gland packing, right?
right.
Yeah. So basically, gland packing is used in pumps and valves as a means of preventing leakage at the entry point of the spindle into the valve body or the drive shaft into the pump impeller housing. So what does this mean, guys? As Raviraj said, so gland packing is basically used to prevent the leakage. Okay. So there is actually a small hole or pin inside the shaft which is sending small amount of water into this gland packing to reduce the heat into the gland packing and to prevent the damage due to the thermal stresses inside the centrifugal pump, right?
We use lantern ring na, or to provide water over
Yeah,
the gland packing.
yeah, yeah. There is a lantern ring provided. There is a water passage inside that. Pump which is pumping the fluid. Water is sent inside that to cool down the gland packing, so that to prevent the overheating of that, right?
Yes, yes,
Yeah. Am I correct or wrong?
yes, yes, correct.
Okay. So that was about the gland packing and sealing. So is there any doubt, guys, about today's session? or have I missed some points, or do you want to add some another points? Anybody?
No, I think all cover it about centrifugal pump.
Yeah. Okay. So, is there anything left, guys? Anything to be discussed?
No, everything is complete now.
Yeah. Okay. So, yesterday's session and today's session, we have completed the centrifugal pump and gear pump. So, these were the top questions prepared by Gan and Avito. Guys,
Okay.
actually, we need to thank them. They have prepared a top 30 questions for ANGLO especially. So, I have picked up centrifugal pump questions from that only. So, let's thank Gan and Avito for these questions, and may he be helping us like this only. Let's learn together. So, I will let you know very soon in the group about tomorrow's topic. Be prepared for it. I will send the message in tomorrow morning. Okay.
Akshay, are you passed in SIMS exam or are you qualified for SIMS?
Yeah, I have been qualified for Sims and Great Eastern.
But why you're not doing?
Actually, I had a medical issue. I had a spectacles and I had a high power. So they had suggested me for a LASIK surgery. And
But
due
please,
to
I need help. I need help. Can you prepare me for SIMS only on SIMS, not at any another one.
yeah, yeah, sure, sure. Actually, look, Gulshan, it is not very tough to clear Sims exam. So
Yes,
basically,
yes, when I was filled the form and last time and I got failed in written exam because I haven't any idea about the written exam.
yeah, okay.
Okay, this time I have a second opportunity, but my application form is not filled. This is showing like of my age is overage for this course. Why it's showing like this?
Oh, sorry, I don't have any idea. What is your age now?
22.
Okay, I am also 22.
Yeah.
So let's discuss it personally. You can
Okay,
call
okay,
me.
okay. You have it when you have time.
Yeah, I am free. You just DM me in WhatsApp. I will call you at the night maybe.
Not a day because I am busy at a college.
Oh, okay. So which college?
Or Sardar Patel University, I am lecturer at.
Oh, okay, okay. Good. No problem. You can call me tomorrow. Actually, Navratri days na, so I am busy in the evening. So I
Okay,
am not.
okay. No, so no, so I will call you after 7 p.m.
Yeah, sure,
at
sure.
anywhere.
Yeah, sure, sure. No problem.
But because okay, okay. Thank you. Okay,
Okay.
bye bye, all of you.
Yeah, bye guys. So should we wind up, guys?
Yes.
So that's it for today. Thank you guys for attending and continue attending the classes or sessions. So yeah,
Yes. Yes.
bye.
Thank you.